to finish lesson 2-3. So you can write 2-3 examples 4 and 5. We're going to talk about solving equations that contain fractions and ways that you can work with them. If you look right here, page 96. All right, I've copied this one down. I want to do that too. The first thing they discuss here is this first method, which is likely the method a lot of folks would start with, and that is finding a common denominator for the two fractions you see. So you see we have fourths and thirds. The multiple that they share then is 12, and then solving the entire equation by turning these two into common denominators. Now the other method is one that I tend to use a lot because it seems to get rid of the fractions. And it's kind of interesting because it's not one that I would always, I don't know that I was taught this when I was in school. And I kind of like this method. So instead of creating the common denominator of 12, you multiply by 12. What'll happen is these two cross cancel, these two cross cancel, and then your fractions, when you're multiplying here, they go away, and then you solve without them. So it's kind of a nice way to work sometimes. It doesn't work for every equation every single time. I mean, the math will always work. It doesn't always make the math easier every time, all the time, I guess, but it's a great way to get rid of them. I'm going to show you how to do it here. So the common denominator they share is 12. So I take this whole side of the equation and I multiply it by 12. And then I'm going to have to balance that and multiply by 12 over here. You're going to end up with 36 over 4. And you can write that or not. So you can write this 36x over 4. And you can write 12x over 3. Because you're distributing. Equals 120. Some people look and go, well, I don't really need to write the 36 over 4. I'm going to say to myself, this is going to cross cancel. 4 goes into 12 3 times, and 3 times 3 is 9. So they would, instead of writing this step, would just go, I know that that's going to make a 9. They'd have 12x over 3, which is going to give you 4. And then your 120. You would combine your like terms and get 5x equals 120. Divide both sides by 5. And get x equals 24. I'm going to show you another one like this. It's just a method I find I use a lot, and most of the time because you can leave this step out if you like, it gets rid of the fraction and shortens up the writing, the amount of writing that you're working with. All right, copy down question number 3. And the first thing you want to think to yourself is, what is that common denominator? Well, 7 and 14 both share 14. So that common denominator is 14. Instead of finding the common denominator 14 and rewriting this as both being over 14, I'm going to multiply by 14. That's going to cross cancel here. And then I'll have 2 times 2 is 4m. When I distribute this 14 over here, it's a new set of cross canceling. 14 goes into 14 one time, and that becomes 3m. And 1 times 14 is 14. 3 and 4 make 7. And you would divide by 7. All right, let's give this one a try. You think to yourself, what would 5 and 4 both share? They would both share 20. So I'll multiply both sides by 20 over 1. When you do your cross canceling on the left-hand side, 5 and 20 would cross cancel and give you 4. And 4 times 2 is 8b. 4 and 20 would cross cancel and give you a 5. And 5 times 3 is 15b. And 3 times 20 is 60. You would add 15 and 8 and get 23b. And you would divide both sides by 23. And this one doesn't turn out to be a real pretty problem, of course. But like Mrs. Pilney said in the last video, it's fine to leave it as an improper. In fact, in algebra, very often it's helpful. If we take a look at this one, 9, 6, and 3, they would all have to share 18. The 9 kind of makes it a trickier game. I was going to say 12, but the 9 makes you have to go out to 18. So multiply both sides by 18. And remember, that's 18 over 1. This will give you cross cancel, and you'd get 2. If you cross cancel here, you'd get a 3, and 3 times 5 is 15. And if you cross cancel here, you'll get a 6, and 6 times m is 6m. If you think about this as add the opposite, you would then subtract 15, and you'd have negative 13 equals negative 6m. Divide by negative 6 on both sides. When you divide two negatives, make a positive, and you would have 13 over 6 equals m. So there's a couple different ways, couple different examples, to kind of look at how you can multiply to get rid of fractions in a problem. Notice how I wasn't multiplying by the reciprocal. I was always multiplying by the denominator. Multiplying by the denominator is what allows you to have this cross-canceling luxury. That's what gets rid of your fractions. Problem 5 shows you a way to also get rid of decimals. It's something that people do a lot. You do it when you long divide. So if you were gonna, say do this math right here, you'd have to slide this decimal over and slide this decimal over before you can start dividing. So we do this kind of math a lot. We're gonna do that here. We're gonna slide those decimals out. The trick is it's an equation, so you have to keep the amount of slides equal on every number. So while one slide would get rid of your decimal, it would put it on the end and it would be gone, technically. Then that's not enough slides, though, for the next two numbers. They each require 2. So if you need to slide 2 at most, then everything needs to slide 2. Now, making a decimal slide once, that's multiplying by 100, or 10, Making a decimal slide twice, that's multiplying by 100. By doing this, you no longer will have a decimal. It'll slide over 2 and you'll get 350. Now the decimal's out here still, but we don't write it then in that case. Slide the decimal over 2 and you get 2x. Slide the decimal over 2 and you get 125. And then you would go about solving this problem. Go ahead and finish this one. Solve it. And your work would look something like this, and you'd have 112.5. I was meaning to do problem 5, but I miscopied it. This should have been a 4, so you'll have a different answer than what you see in the book here. Sorry, my chair is like the squeakiest chair in the world. You can see other examples here. Let's look at this got at 5. You'll notice how you have 0.5, 2.325, 3.95. Think about what you might need to multiply by in a situation like that. At max, we need 3 slides total, so every number will have to be multiplied by 1,000. Let's try an example here. I think this number 4 looks pretty good, so we'll copy that one down. You're going to need 1 slide at most. They all require only 1 slide. So we'll multiply everything here by 10 and everything on this side by 10. That'll give me 12 equals 24 minus 6x. You'll subtract 24 from both sides. That'll give you negative 12. When you bring this 6 down, don't forget to consider that it is a negative 6. You don't always have to write that step, but just remember that sign in front of the 6, it's going to have to travel with that 6, giving you negative 6x, and divide both sides by negative 6, and then you have 2 equals x. Since we're going over different methods to kind of make things easier, I thought I would show you a division property that you can use with the distributive property, which I think is really handy to know. So I'm going to copy it down real quick here. If you want to copy down this number 2, I'll show you. So most of the time you want to distribute, but you don't actually have to distribute. You can solve this using division instead of that multiplication if you want. Now, it's important to note that there's parentheses here. So this sort of acts like it's one item. So it's sort of like saying 2 times x equals 24, for example. When you go to undo the multiplication of 2 times this grouping, you're going to undo by dividing everything by -2, like that. When you do this, this is going to be gone, and you would have 3x plus 9 equals -12, and then you would keep solving. And you'd have 3x equals -21. You would divide by 3, and you'd have x equals -7. It's really important that you understand that when you do this sort of division, this isn't being affected by it because it's saying 2 times this grouping, and I'm going to undo that multiplication, leaving me with just the grouping. That is in the same way if you were to take 2x and divide it by 2, it would leave you with x. This leaves you with the grouping afterwards, what's in the parentheses. All right, so if we try that again here with this number 7, I would say I want to get rid of this 7. And remember, this is an option to use if you don't want to distribute. It's just something to know. It's kind of handy. So I'll divide both sides by 7, and I'll have, 3x minus 4. Now that there's nothing outside those parentheses, I can get rid of them. Equals 49 divided by 7 is 7. Add 4. 3x equals 11. Divide by 3. And you'll have x equals 11 thirds. And you can say 3 goes into 11 3 times. You get 9. You'd have 2 left over. If you want, it sort of depends on the problem and what you're working with too. That's a division property to solve. So you can distribute if you like. You can try the division property if you'd like to. It's just another way to work with those parentheses.